Welcome back. This lesson is going to expand on what we talked about in the previous lesson about graphing linear equations using tables. We're going to use tables again, but this time we're going to only graph using intercepts. So take a look at this page, read through the objectives, the vocabulary about intercepts, and then graphing using intercepts, and then we'll move on and go through some examples. Okay, in the first example, we have x minus 3y equals 6, and we're supposed to graph the linear equation using intercepts. And in this case, you can see we have a table set up for us. The table only has 2 rows in it, and it has 2 numbers already in the table. It has 2 zeros. And so when we put zeros in the table like that, what we are finding is the x and the y intercept, because when x is 0, we find the y-intercept, or we find the point where the line crosses the y-axis. And then when y is 0, we find the x-intercept, or the point where the line crosses the x-axis. Okay, so some people find this easier than doing it where you have to pick your own numbers to put in the table. And I do find this easier because working with zeros is really easy. So for example, if we look at this equation and we plug in a 0 for x, we have 0 minus 3y equals 6. So essentially what happens is that x term just disappears. So we have negative 3y equals 6, and when we divide by negative 3, we end up with y is negative 2. So we can put a negative 2 in our table. And then similarly, when we have y is 0, we have x minus 3 times 0 equals 6. That minus 3 times 0 disappears, so we end up with x is equal to 6. So in that case, we didn't have to do hardly anything, so we just plug in a 6 into our table. And then graphing is rather simple too, because we don't even really need to do much as far as identifying how many lines we need on our graph or how many numbers we need on our graph, because we're just going to have 2 points. And if we think about the first one, we have 0, negative 2, and the negative 2 is a y value, so all we need to do is find negative 2 on the y-axis. And for the second one, 6 is an x value, so all we have to do is find 6 on the x-axis. So we go over here, and I'm just guessing roughly where it's going to be. It doesn't have to be perfect, and this looks fine. So then we have 2 points, and since we only need 2 points to create a line, we can go ahead and connect them and put arrowheads on either end to identify that it goes on forever. Okay, so relatively straightforward, quick and simple, especially when you have an equation that is in standard form like this, because the x term disappears for one, the y term disappears for the other. Okay, so let's look at another example. And this one isn't in standard form, it's not in slope-intercept form, it's kind of in a goofy form where we have x by itself on one side and 3y minus 9 together on the right-hand side. Now, one thing we could do to make this easier is to turn it into standard form. And I'm actually going to do that. So I'm going to subtract 3y from both sides. So I end up with 4x minus 3y equals negative 9. And to me, this is going to be a little bit easier when I create my table of x and y values. Remember, I just want 2 zeros in there, one for x, one for y. And then when I evaluate this thing, when x is 0, I know that that 4x disappears. So when x equals 0, I end up with negative 3y equals negative 9. Or divide by negative 3, y is equal to 3. So I can go ahead and put that in my table. And then when y is equal to 0, now this one gets a little bit goofy because we can't divide negative 9 by 4. So when y is 0, the negative 3y or the minus 3y disappears, so we end up with 4x equals negative 9. And then when I divide by 4, I get x is equal to negative 9/4, which nobody can really visualize very well. So we know we want to make that a decimal, and so in this case it happens to be equal to negative 2.25. So we can put that in our table. Okay, and then same thing when we graph it. all we have to do is find those 2 points. So the y value is 3, so I'm going to go up here to 3. The x value is negative 2.25, so it's somewhere over here. And again, it doesn't need to be exact. And then I can connect those 2 points, something like that. So there we just graphed that line. And this one, seems like it should be harder because of that decimal, but really it's just finding a point on that x-axis where that negative 2.25 is roughly at. Okay, last one. In this case, we have just a y equals negative 3. And if you remember from the last lesson, when we have something like y equals negative 3, it is a horizontal line. And it's a horizontal line at negative 3, so I'm going to go ahead and graph that. And when you do that right there, what you've just done is you've plotted the y-intercept. So in this case, it's a horizontal line. Okay, and this is negative 3. It's a horizontal line at negative 3, so that means it's not going to have an x-intercept. Because a horizontal line is parallel to the x-axis, it's never going to cross the x-axis. So in this case, this is an example of a linear equation that only has one intercept, and it has a y-intercept. All right, there's an assignment on Schoology, so go ahead and take a look at that. And when you are done with that, you can submit it, and I'll take a look at it for you.